Let us start with second topic under part 2 of unit number 4, that is RNN, recurrent neural network. RNN, recurrent neural network. As you know, neural network consists of input layer, set of hidden layers, and output layer. So recurrent neural network is nothing but a neural network which follows interdependency. What is interdependency? Interdependency is nothing but an activity where output of previous component acts like input for the next element. RNN is a type of neural network where output from the previous step is connected as input to the current step. That means output of one component acts like input for another component is said to be RNN. In the case of conventional neural networking, whatever the input and output we have, all those are independent. Whereas RNN is considered, it provides you a dependent. For example, in the traditional networks, all inputs and outputs are independent of each other. But in the case where it is required to predict the next word of a sentence, the previous words are required, and hence there is a need to remember the previous words. So it is not at all feasible for us to remember all the components that are related with the previous one. In order to solve this problem, RNN came into existence. So it can solve the problem by using a hidden layer. What is that? Hidden layer. Very simple. RNN is a type of neural network where output from the previous layer or a previous step is connected as a input for the current step. So in the case of traditional networking, where we have to remember all the previous states, whereas RNN is concerned, there is no need to store all of previous words. The most important feature of RNN is its hidden state, which remembers some information about the sequence. This state is also called as a memory state, since it remembers the previous input to the network. So it can also use as the same category of parameters without any kind of additional parameters for each input, as it performs the same task on all input or hidden layers to produce output. So it reduces the complexity of parameters unlike other neural networks. See, all these sentences define you first two parts related with the definition, third one related with a hidden state, also called as memory state or a sequence. It always uses the same category of parameter. See this. This is a recurrent neural networking, a schematic diagram of RNN. In this case, here there are two levels here, RNN, RNN unpacked. See, this is RNN, it produces output. The same element will be connected with another RNN, join and grant OR. Whereas this recurrent is considered, this component can produce, here this is an input and it process and produce output, but the same activity can be connected as input. The high level structure of recurrent neural network is here. On the left, the purple line indicates the loop that passes information between the steps in the network. We can have, this is unfold activity, this is a separate activity. This diagram is also defined like this. How RNN works. RNN consists of number of activation function units. Each function unit exists for one step or one timestamp. Every unit has internal state. That state is called as a memory state or hidden state of that unit. I told you every state contains information related to the past knowledge that the network currently holds at a given time step. This hidden state is going to be updated every time step to signify the change in the knowledge of a network about the past. Here, the hidden state is updated using the following recurrent relation. Ht is equal to f of ht minus 1 comma xt. See, aht is nothing but a current state. Ht minus 1 is nothing but previous state. Xt is nothing but input state. I think you all are full aware of flip-flops and latches in the case of digital logic design or computer organization architecture. In the case of flip-flops, RS, T, JK, etc., master slave, etc., output of one component acts like input for another component. It's a feedback connection. Like this, it always holds the previous state information. Formula for applying activation function, that is tan h, that is ht is equal to, just now I told you ht is equal to current state, ht minus 1 is equal to previous state, xt is equal to input state. Tan h of wh ht minus 1 plus w h xh xt, it is weight at the recurrent neuron, weight at input neuron, it. The formula for calculating output can be determined by using YT, whereas input can be determined by using XT. Output, weight at output layer, YT is equal to WHY HT. See, whatever the parameters which are available in the case of RNN is going to be updated by using a technique called back propagation. This back propagation is also known as back propagation through time. So since RNN works on sequential data, I told you everything is a sequence. We use an updated back propagation, which is also known as back propagation through time, BPTT. Remember this full form, back propagation through time. So a neural network is an ordered fashion because it's a sequence linear. Since it is ordered network, each variable is calculated one at a time in a specific order. First H1, then H2, and then H3, and so on. Hence, we will apply back propagation throughout all these hidden states sequentially. See this? L0 is a loss function, L5. It is a loss function, depends on H3. H3 in turn depends on H2 and weight W. H2 depends on H1 and W. H1 depends on H0 and W. And then H0 is a H0 is nothing but a constant starting state. So very simple. It can also be represented like this. Training through RNN. See, RNN is going to execute everything in the terms of activation function to time state. All these components are executed in a sequential fashion or a serial fashion or a sequence memory state. In general, a single time step of input is provided to the network. It calculates its current state using set of current input and previous states. The current state is ht, becomes ht minus 1 for the next step because the output of previous component acts like input for the next component. That's why present input acts like a previous input for the next step. The current ht becomes ht minus 1 for the next time step. One can go as many time steps according to the problem and join the information from all the previous steps. That's why I told you in the first step itself, in the case of traditional mechanism, traditional neural networking, you need to concentrate on all of previous states. You need to remember all the previous states information. Now, there is no need to remember all previous information because every component acts like input for the next state. Once all the time steps are completed, the final current state is used to calculate the output, and then The output is then compared to the actual output, that is target output, and error is generated. See, what is the exact output? What is the actual output? If both are equal, there is no error. But there is a deviation, definitely error is generated. The error is then back propagated to the network to update the weights, and hence RNN is trained by using back propagation through time. For example, if there exists any error, that error need to be corrected or verified and removed based upon back propagation technique. That's why I told you back propagation through time. Architecture of RNN. Recurrent neural networks have the same input and output architecture as any other deep network architectures. There exists a difference in the terms of information flow. I told you in the second slide, the diagram. And then, however, differences arises in the way information flows from input to the output. Unlike deep neural networks, where we have different weight matrices for each dense network in RNN, the weights across the network remains the same. It calculates the state, hidden state, Hi, for every input Xi by using the formulas H, Y, and Y. S is a state matrix, time step I, and the parameters in a network weight, U, V, C, B are shared across time step. This is, see, dense. There is a dense layer, RNN cell. I told you this is RNN. This is a normal sequential. Everything is connected with X0, X1 up to Xn will be connected with dense. Training. Just now I told you every layer is going to provide input to the current state so that there is no need to remember all of existing elements. Advantages of RNN. RNN remembers each and every information through time. It is useful in the time series prediction only because of the features to remember the previous input as well. This is called long short-term memory. That's why I told you the first point itself, that is a memory sequence. It can also be used even with the convolutional layers to extend the effective pixel neighborhood. The effective pixel neighborhood elements can be connected by using RNN. But the disadvantages. Gradient vanishing and exploding problems may occur. Training RNN is very difficult task because we are going to compare the output with the exact output or expected output. If there exists a gap in between, you have to perform back propagation technique for training. It cannot process very long sequences if using TANH or ReLU as an activation function. Next point, next topic is RNN is very important question. Multi-channel convolution operation. See, I told you convolution is nothing but combining two or more components to produce one. In general, we have multiple filters in a given convolution layers. We already calculated filtering applications in the case of representation logic. Each filter allows a network to learn a representation of the data at a given layer in a unique manner, individual manner. For example, we have various categories of cells. The first hidden layer in network is a convolution layer. It may contain a kernel, what you call a core, that is going to respond optimally to a vertical line. So that means every component may have multiple number of layers. Those components may have a single component, what as a core component called a kernel, that is going to respond in an effective manner to vertical lines. Whenever it convolutes, a vertical line in an input image is producing large activation value. I told you activation function in the case of previous part. Activation function decides whether a neuron should be activated or not. It means that it will decide whether the neuron's input to the network is important or not in the process of prediction. For example, if the importance of neuron is high, that particular neuron will be activated in order to produce a prediction. If the neuron may not be activated, which means that the activation of neuron may not be important. There are several commonly used activation functions such as this, softmax, stan-H, and sigmoid functions. Each function has a specific usage. The number of filters in the layer, like the number of neurons in a dense layer, is a hyperparameter that we configure ourselves. As with other hyperparameters, there is a Goldilocks sweet spot for filter number, set of rules that is creating for a particular problem. Having a large number of kernels to produce identification of more complex features. For example, whenever we have a number of layers, automatically we can handle highly complicated problems. So that more kernel comes with the cost of computation efficiency. Whenever a network has what you call neural network has multiple convolution layers, optimal number of kernels for a given layer could vary, change quite a bit from the layer to the layer. That is, in the case of complex recombination of simple features, there is a stack of your network. Stack is nothing but collection. Strive to minimize the computational complexity manages. Here we have low cost on validation data. You are going to doubling the number of kernels, 32 to 64, 64 to 128, etc. So automatically validation cost may be increased. Say this. This is RGB image, red, green, blue. Here we have. These are the images with the intensity or some kind of pixel values. This is green and this is blue. These are the weights. Already I told you in the previous sessions how to calculate this. Z value, here summation of Z, all these functionalities to produce the required outcome. This is. In the same manner, the process is repeated. See, here this is selected, this is selected, this is selected, and this one is selected, this one and this one. That means image, pixel value, and weights are combined together to produce the required outcome, that is 2.64, 4.27. This process will be executed. We can produce the every possible filter position. Z value that was calculated for each of these 9 positions is shown here. Convolutional hyperparameters. See, in this case, we have kernel size. Here, all of the examples covered, the kernel size, also known as filter size, has been 3 pixels wide and 3 pixels tall, what you call 3 into 3. A kernel size of 5.5 into 5 pixels is also popular. 7 into 7 is about expensive as they ever get. I told you, whenever the kernel size increases, number of filters increases, automatically validation function cost increases. Stride, it is a parameter of neural network filter that modifies amount of movement over the image or a video. Padding. Padding is a term. In many cases, we have a concept called a padding. Padding is nothing but adding of something which is being processed by the kernel. In any area, padding, I think in the case of computer networks, Ethernet, in the case of 802, IEEE 802.3 frame format, we have a concept called a padding. In order to satisfy the minimum length, we are going to add additional bits, what you call padding. Padding is a term relevant to the convolutional neural network as it refers to the number of pixels added to an image when it is being processed by the kernel of CNN. See this? These are the values, this is the kernel, and this is the final outcome. RNN code. Adding a recurrent layer to the neural network architecture to create an RNN is straightforward in the case of keras. I told you the keras in the previous sessions. We illustrate in our RNN sentiment classifier Jupyter notebook. As you know, Python, Jupyter. Loading of dependencies, except that there are often 1 or 2 additional dependencies in a given notebook. Loading of Internet Movie Database Film Review, IMDb. IMDb is nothing but Internet Movie Database Film Review data. Standardizing review length, compiling the model, creating the model checkpoints, creating the model checkpoint object and directory, fitting the model, loading the model parameters from the best epoch with the critical exception that the particular area we select to load the varies depending upon which component has lower validation loss, predicting Y for all validation data, plotting of histogram. I told you histogram is nothing but some kind of representation in the terms of bars, calculating ROC, AUC. The code cells that vary or set hyperparameters, design the neural network architecture. These are hyperparameters for our RNN, or here RNN sentiment classifier hyperparameters, output directory, model output RNN, recurrent neural network, and 16. Training component may be 16, batch is equal to 128, and dimension are 64, unique words are 10,000, maximum review level length is equal to 100, padding type is equal to truncation, drop embedding is equal to 0.2, the n number of RNN layer architecture 256 and 0.2. This is a sentiment classifier architecture from Keras layer import simple RNN sequential model is equal to sequential. We are performing embedding adding of something and then spatial dropout ID simple RNN and creating sigmoid. Next concept is very important concept, that is PyTorch. PyTorch. PyTorch is an open source machine learning library used for developing and training neural network based deep learning models. What is open source? Without having any kind of license, you can download it and use it. It is primarily designed by Facebook Artificial Intelligence Research Group. It can be used with a Python as well as C++. Both are object-oriented languages. PyTorch is immensely popular in research labs, unlike most other popular deep learning frameworks such as TensorFlow that use static computation graph, whereas PyTorch uses dynamic computation, which allows greater flexibility in building complex architecture. All of previous components may have a static component, whereas PyTorch uses a dynamic. It uses core Python concepts such as classes, objects, structures, loops, or any other component, which is very simple to understand. PyTorch may provide very simple than other frameworks such as TensorFlow that brings in their own programming style. These are three basic deep learning framework models: TensorFlow, Keras, and PyTorch. PyTorch is a machine learning framework called Torch, which is based in the programming language loop. It is really an extension of Torch designed to feel fast and intuitive in much more widely in Python language. See, PyTorch, the name itself represents Python. It was completely written and specifically defined to feel native to the people familiar with the Python while retaining the computational efficiency of original Torch library. By keeping all the features in the case of Python, at the same time, the computational efficiency of a Torch library is also retained. PyTorch performs matrix operation like NumPy. What is NumPy? It is a Python library used for working with arrays. It also has the function for working in the domain of linear algebra, Fourier transformation, and matrices. Because of this deep integration with the NumPy, several additional layers can be directly written in a Python if this extra flexibility is desired. See, PyTorch is providing high-speed libraries because all of our acceleration libraries are built in, which help to make PyTorch fast regardless of device. Custom memory allocators enable it to be more memory efficient. Why PyTorch? eager graph-based execution, dynamic neural network, distributed training, hardware accelerated inferences, simplicity over the complexity. The fundamental units within PyTorch. Basic operations with tensors. I told you TensorFlow. Tensor is little more than the fancy name for matrix or vector. Tensor functions functionally in the same way NumPy arrays, except the PyTorch provide specific mechanisms to provide computation with them on graphical processing units. I told you all of existing components are static, whether PyTorch can provide you dynamic. The default tensor is usually float tensor. It has 8 types of tensor, which contains either integer or float. It may have, in the terms of precision, 8-bit integer can only store 256 values, which means that 2 power 8, that is 0 to 255, and occupy much less than 64-bit 7 integer. In the cases, integers up to 255 or all that is required, higher order integer would be unnecessary. See this torch zeros, 28, 28, 1 data type. D type is equal to torch.unit8 and 43. Automatic differentiation. These components store the computational graph for the network as well as the gradient. It requires gradient arguments to true when you create the tensor. See this gradient argument is equal to requires gradient is equal to true. And backward method is defined. Backward method reverses through the record of operations and calculates gradient at each point in the graph. After the first call to the backward, the gradient attribute becomes filled with gradient values. How PyTorch works. It uses unique features to write readable code. It also popular for its usage of dynamic computation graph. It enables many people to run and test a portion of code in real time instead of writing the total program. See, if you want to execute anything in general, any programming language may accept the total component need to be completed, then only we can execute. Whereas PyTorch is concerned, there is no need to write the total program code. Even though you write something, you can directly execute without completing the total program. It provides following key features: tensor computation, touch script, dynamic graph computation, automatic differentiation, Python support, variables, parameters, modules, functions, etc. And then deep learning with Python. PyTorch. I told you there are 3 categories of framework as far as deep learning is considered. Number 1 is TensorFlow, Keras, and PyTorch. See, better deep learning model can be provided. Training deep learning model will be provided by PyTorch because of it seems to be Python. It seems to be Python and uses all the concepts of Python. Beyond Keras, TensorFlow, and PyTorch, there are various other deep learning libraries out here. That is MXNet, which was developed by Amazon, CNTK, Microsoft Cognitive Toolkit. Cognitive is nothing but brain learning ability. KEF, out of University of Berkeley, and then Techno, University of Montreal project. So if Python does programming, PyTorch provides an excellent introduction to deep learning. At the same time, PyTorch has been proved to be fully qualified for the use in a professional context for the real world high profile work. It can provide you better API, application programming interfacing, easy debugging, which make it excellent choice for introducing a deep learning. We highly recommending PyTorch for your deep learning. Key benefits of PyTorch. It provides easy to learn, simple to code structure because it is based on Python. Enables easy debugging with popular Python tools. Offers highly scalability. What is scalability? You can increase and decrease, and well supported on major cloud platforms. Provide small community focused on open source. exports learning models to the Open Neural Network Exchange ONNX standard format, offers user-friendly interfacing, provides C++ front-end interface options, includes a rich set of powerful API that extended to PyTorch library. CNN in PyTorch. See, PyTorch is a tensor multi-dimensional array which always provides you a dynamic component. Its unique feature is graphs are dynamic when directly in Python can be modified during runtime. CNNs are the basic architecture used in deep learning for computer vision. Torch.nn library provides built-in functions that can create all building blocks of CNN architecture: convolution layers, pooling layers, padding layers, activation function, loss function, fully connected layers. This is a simple code for PyTorch. This is a code: CNN layers, sequential, convolution, batch normal, and then max pool, etc. PyTorch versus TensorFlow. Sometimes they may ask you differentiate PyTorch and TensorFlow. PyTorch is often compared to TensorFlow, a deep machine learning framework developed by Google. Because TensorFlow has been around longer, it has greater community of developers and more documentation. PyTorch does have advantages over TensorFlow. It is dynamically defined the computational graph rather than static approach. Dynamic graphs can be manipulated in real time. TensorFlow has a steeper learning curve. PyTorch is based on simple Python. TensorFlow may be better suited for the projects that requires production models and scalability, as it was created with the intention of being production ready. That means customized. PyTorch is easier and lighter to work with, making it a good option for creating structures called prototype quickly and conducting research. So this is the information related with RNN, multi-channel convolution layers, PyTorch, PyTorch code in the case of RNN and CNN architecture. That's all.